Kumar. I'm doing my master's in cloud computing. As part of my third semester research subject, I performed research in the fog computing load balancing algorithm. I designed and configured an computation-based load balancing algorithm. It will assign the task based on the capacity of the RAM sizes of the fog node. Cloud computing is also exists. It having the many issues like delays, distances, bandwidth, cost of execution, energy consumption, and energy consumption. Why? Because these are data centers are far from the users. There is a there's a queue, a long queue of requests which are waiting in the queue, and also IoT devices usage is increased, so the data generated by them is very high. So because of that, energy consumption is high in the cloud computing. Cost of execution is also high because they're the biggest data centers, lot storage competition is required. So that is the reason. In bandwidth, this everything is done. And fog computing is not a new thing. It's an extension of cloud computing. That means which are like small data centers which are placed near to the end user. This is the three-tier architecture. Cloud data center, top one is a cloud data centers. These are called fog data centers. And these are IoT devices like in healthcare applications and also automatic cars. We required and quick responses. So in that case, fog computing is the most suited for these applications because we'll get the quick responses and the latency is less, bandwidth is less, and we'll get the better resources, better uses of resources as well with the less usage of resources with a greater output. So these are the challenges in the fog computing. Like every technology has every as into the fog environment, load balancing, quality of services, energy consumption. These are the most research areas in the fog environment. Quality of services, there are like several parameters which comes into that, which that means they want to use the less resources and they want to provide the better services like latency, delay, bandwidth, network, and energy consumption and everything. And load balancing algorithms is designed by many people. There are like many load balancing algorithms are there. Many suggestions are done by the researchers. One is the Fusi Golden Eagle load balancing and Golden Eagle load balancing algorithm. The main idea of this concept of the load balancing algorithm is like they are giving the priority based on the deadline time and the task size, and so based on that, which has the less deadline and task sizes, they will be executed first. Let's coming into the other load balancing algorithm, practical swarm optimization and anti-colony optimization algorithm. In this, the anti-colony optimization chooses the shortest path for completing the task. PSO algorithm is perform the task offloading methods. And let's coming to the few other algorithms like energy aware load balancing algorithm. This is my core paper, and from this I took the inspiration for designing my computation based load balancing algorithm. So my main idea is like the tasks are assigned based on energy level of the fog nodes. There are other algorithms are there, min scheduling. In this, the task which takes less time for execution will be completed first, not on the importance of the task, like which require quick responses. If they are taking the more time, they need to wait in the queue. Then we can achieve efficient resource allocation algorithm. In this, the tasks are distributed according to which ones consumes less amount of energy. Not only these load balancing, there are many load balancing algorithms are there, but these algorithms are very uh, close to my paper, very related to my paper. That is the reason I selected this. Let's coming into the simulators are tools which are used for my implementing the computation-based load balancing algorithm. The main components in the IFOG simulator are fog devices. Fog devices is nothing but a small data centers which has computation, storage, and everything. Sensors which will collect the request or which generates the requests. Actuators Executators is nothing but is used to perform the actions which are sent by which are sending the from the tuples. Tuples are it acts as a communication between the fog and also the architectures levels. And applications is like scheduling or placement of application because in our fog simulator everything is application or the module. Let's coming into the cloud analyst tool. Why use the other tool is like I am designing the iFog simulator. Uh, 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 Coding in the iFog simulator in the Java programming language. In the cloud analyst tool, they are like key components are there, and also the few default algorithms are there. My implemented algorithm, I want to I'm taking the comparison with these algorithms which are existed in the cloud analyst tool. In that case, I can say that by default algorithms, if it performing the better, I can say that this performs the better. In a few cases, if those are performing the better, I can say that which is performing better. So the key components in the cloud analyst tool are region. Region is nothing but the areas. Data centers is like a for small fog nodes are the small data centers which can able to perform the operations. Virtual machine load balancer, it helps to helps to know the which virtual machines are available for the task completion, and who which is not which is handling less load and everything. User bases are nothing but it just like users from group of users which generate a request to the data center. Like cloud service broker policies, it's just like some service broker policies are there, like closes data centers and it is everything. So based on different characteristics, different application, different categories, it performs the better. And I told you there default algorithms are there. We can select and we can run the by choosing the algorithm we can run. So one is round robin. Round robin is perform. It just it's an scheduling algorithm. It's an static. It performs it assigns the task in a circular manner, and also it provides a specific time slot for the operation. It works on first come first service based total load balancing algorithm. In that, data center controller and virtual load balancer algorithm are there. Virtual load balancer algorithm is helps to know the what are the virtual machines are available, and data center controller it will tell to the data center controller. Data center controller will assign the task to the virtual machines. Equal spreads current execution load balancing algorithm. In that also, data center controller and virtual machine load balancing algorithms are there. In the virtual machine load balancing algorithm, which has the knowledge of which data center, which virtual machines are free, and then it will tell to the data center controller. Then data center controller which assigns the load to the to the virtual machines by distributing the load equally uh, on the virtual machines. So this is the implementation. This is the implemented algorithm. My implemented algorithm is a computation-based load balancing algorithm. In that, the requests are collected from all IoT devices. The main idea of this is like the first of all, it will collect the request from the users, and it will check the load. This is the flow chart. I will explain the requests are collected, and it will check the connected fog nodes, and it will check the load. If it not overloaded, it will assign the it will check for the capacity. If the fog node is overloaded, it will check the other fog node. If after meeting the load requirement, it will check the RAM capacity of the fog node. If it's not, it will assign the next nearest high computational fog node. Otherwise, it will if it meets, it assigns the task and completes the task. This is the implemental algorithm. So it will create the application just like a for finding the way. I designed a competition based load balancing algorithm for finding the vacant room in the hospitals. So in that, I'm using the in the camera. It will do the picture capture sensoring. So that is the reason I use the picture capture here. And this is the floor finder. Floor finder is just like a fog node which helps perform the operations. And these are also based on the areas and everything. It will assign the task and it will. I will explain this in the coding section. And this is the configurations which are designed for network topology. This is the network topology. Cloud is the highest level -1, and proxy servers are comes under the one, and fog nodes are coming into the level 2, and one is the camera, and other one is the flow, and other one is the actuator which perform the actions like I use the LED which turns the LED on if there is a vacancy in the room. After implementing the algorithm, I took the comparison analysis. By comparing the analysis, I took it from DCNS algorithm from iFog simulator. For cost of execution, the proposed one is the best suited, and network usage is also less by comparing with the default algorithm. It is also by compared with the DCNS. Ines algorithm in the IFOG simulator, and average energy consumed. This is also this energy's consumption is compared with the cardiovascular health monitoring application. And I taken the different comparative analysis which shows that which is the best one and which is the best suited for the application. And proposed one is energy consumption is less by comparing with the default one. When coming into the latency, when I compared in the iFog simulator, the latency is less in the by the default algorithms. When I compared with the cloud analyst tool latency, the cloud analyst the existing algorithm, the default algorithms performing the better than the proposed one, like round robin throttled and equally spread execution algorithm. They have performed the operations within a milli of seconds. My operation is taking the in seconds. And advantages are the bandwidth is reduced, less energy consumption, and reduced cost and reduced latency. When I coming to I will conclude that like maybe I achieve the distribution of load on the fog nodes based on the computation power. If the nearest load capacity is less, and also with the load equal distribution, less usage of resources is achieved with improved quality of services. That means less usage of network use, cost of execution, energy consumption, so quality of services improved in the future. As also the computation, we can include the energy of the fog node. If the energy and also the computation capacity meets, then we can assign the task, and also it has to be tested in different case scenarios in order to implement in the future. Let's coming into the coding section. And this is the coding section. This is the IVOG simulator where I designed my Java programming language for the implemented algorithm. And I will show you. I will tell you step by step. Number of areas is nothing but the number of regions which we are required. Number of areas per camera, how many cameras we required for area, the per region or the per room. Here number of areas is nothing but the number of rooms are that is nothing but is here cloud is equal to false. If it is a cloud is equal to true, it will send the operations directly to the cloud, not to the fog data centers. Then energy consumption, everything is high. When you compare with the even fog nodes, coming into the fog nodes, I divided the entire fog nodes into even and fog node based on the number 0, 1, 2, 2, 2, 3, 4. Odd even numbers of fog nodes comes have the same RAM size. Odd number of fog node has the same RAM sizes. So based on that, it will assign the task. If the cloud is equal to true, then this is the cloud application which will be created, and then it will assign the cameras. It will in number of areas. See here, so here number of areas. Sorry, number of cameras will be taken into the consideration, and it will be created and it perform the operation. If it is a cloud is equal to false, the condition which we are having right now, it will create the applications which I created here. It is a cloud data center. It's an highest data center. It is an highest head point, and it is the parent ID is -1, and RAM parameters, there's parameters, and next is the proxy server, and it is below the cloud. It is below the cloud, so that is the reason it is taking the cloud dot get parent ID, because it is above that, it is taking this parent ID. So that means it will get this current parent ID as -1. So those both are linked. Let's coming into the let's coming to the creation of fog nodes. So fog nodes is nothing but a floor finder. Is nothing but a fog nodes. So here fog nodes are divided into even fog nodes and also the odd number of fog nodes. Even fog nodes has some memory size, and odd fog node has the some other RAM sizes. Let's take it to the consideration. If the available RAM, if meets the request, then it will perform the normal operation. If it does not meet, then it will assign to the module RAM. That is the reason I'm taking the comparison. If module is greater than the available RAM, and it will assign. Otherwise, it perform the operations. And here camera is linked with the picture capture, and picture capture to the floor finder to the PTZ control, PTZ control camera, and to the floor finder, and everything is linked. So let's run this application. So let's run the designed application where I will show you the different results and everything, where we can get to know that which is proposed of the next one. Let's take like the RAM size of the event fog nodes have the less sizes, and the requests are rising from them is if we have the less requests, it will perform. Otherwise, it won't perform. Like maybe if you have the more requests, if the RAM capacity doesn't meet us, it will say that it's not assignable. It's terminated. I will run this code. So let's show me. I will show you the results. Now you can see that the available RAM is the 3000, but we are having the request of 5000. So 3000 is less than comparing to the 5000. So that means it doesn't meet the capability. So that is the reason A0 is comes under even number, even fog node. It does not created. And A2 is also, I told you, A2 is also the even fog node doesn't have the RAM capacity. So that is the reason energy consumption and everything is and the latency is 51 seconds for completing these operations. And A1 actuator 1 is camera 1. Actuator 2 is like it doesn't have the capacity. Actuator 3 it is assigned to the camera 3. And for camera 1 and for A1 is taken 0, 1, 2, 3, 4, like that it is assigned. Let's take like maybe if it meets the capacity, if it meets the capacity of that, then if you take while running the application. So here the well, right now we are getting the request again 5,000, but we have the now is RAM is 8,000. I changed the RAM now. So after changing the RAM size, we'll get to know it is taking less. Now previous it is taking 51 seconds. Now it is taking only 49 seconds. Now A1 is and now actuator is 0 and camera is assigned it to the fog node 0, fog node 1, fog node 2, and fog node 3. So there the four fog nodes are assigned and performed operations. When coming into the other tool, which I use is the cloud analyst tool, there are like 6 regions, and each region has one data centers, and we can configure where we want and everything. Data centers region is nothing but see based on the regions, region 1, 0, 1, 2, 3, 2, 3, 4, 5. So we can set the where we has to keep where we need to keep the user base as nothing but the users will generate the request. So where we can know the regions, which regions you want to keep, and which region you want to place the user base, where we need to keep the data center. It's totally user base. I told you that service broker policies are there. Different service broker policies are available for perform the operations for different conditions. Well, coming to the data center configuration, where we can configure the data center. While you click on here, where we can configure the memory, storages, bandwidth, number of processor, how many processor you required. And if you want to add, you can add the other processor again. So that is the reason here. Total two processors are there. Here we can change the virtual machines and cost, and also the storage cost, memory cost, and everything. This is totally data center configuration. When coming into the advanced sections, where we know that grouping how many requests we need to send, what are the load balancing algorithms which are existed, we can take into the comparison. I already shared one configuration. I will run that configuration in the video itself. So when I loaded that, done. So now I created the data center 1 and data center 2 in region 0 and 1. User bases 1, 2, 5. So these are the regions where I created in the region 3, region 4, region 5, and region 1 also I created. When I run the simulation, it is taking now it will sending the request to the data centers, and it will take some time to perform the operations. Then it will generate the requests. So here we can see that here also we can see that virtual missions are created, user bases are created, service broker policies are applied. So here is the less average milliseconds where the task is performed. So as part of my research question, I achieved the computation based, I achieved the less quality of services, and I improved the quality of services. I use this as my research part is comes into the resource management section. And thank you.